number of independent properties to fix the state of the system. Yeah, and we will see this from this figure. That is, let us consider a phase, only one phase, that is water, H2O. We are going to find out the degree of freedom, that are the minimum number of properties is the degree of freedom. We are going to find out how we can define the water, and what are the minimum number of properties required to define the only phase water, liquid phase water, H2O. Okay, C is 1 because it is only one phase, so it is C is 1. So 1 plus F is equal to 1 plus 2, so F is equal to 2. That is, if we have to describe the water, we need two properties. Minimum two properties are required to describing that is temperature and pressure. By experiment we know that the temperature and pressure, two things we can define the water. It should have a specific temperature and it should have a specific pressure for a specific phase of water. For liquid phase it has a certain amount of temperature, or if certain amount of temperature change, it can be the vapor or it can be the ice. And similarly in case of the pressure, certain amount of pressure, it can change its phase. So two properties, temperature and pressure, can define the water H2O. Now if there are the two phases, steam also H2O and water also H2O, means composition are same, so that is why composition is always taken 1 over here. C is 1, P is equal to 2. There are the two phases, and we are going to find out the number of degree of freedom, that is F is equal to 1 in this case. So if two phases of water are available, then we can define it by only one property. It could be the temperature or it could be pressure. Only one is enough to define that. But if three phases are available of H2O, steam, water and ice, then the composition is only one because it all are the H2O, and phase are 3, so number of degree of freedom F is going to be the 0. That is, all the properties are fixed. All the properties are fixed, and it does not need any properties to describe it because all the properties are fixed over here. So this is a triple point of water. In this case it is called as a triple point of water, and the triple point, the temperature is 0.01 ounce centigrade, which is the 273.16 Kelvin, and pressure is 0.6117 kilopascal at triple point. So remember these two, TTP and PTP, is a triple point temperature and pressure, and in triple point chart you can find out this pressure and temperature at this point. All the properties of the water are fixed, and from this point you can find out the single composition H2O, which is available in three phases: steam, water and ice. Yeah, after defining these all the things, we must know what is actually the pure substance. So remember these really important things to know the pure substance. The definition of the pure substance is homogeneous and invariable chemical composition irrespective of phase is known as a pure substance. Process and path is our next topic. So change of state is known as a process actually. Change of state, the state, we have seen that a point or a coordinate, that is a property which describe the state, that is P1 and V1 point is meeting at one place, that is a state, that is a property describing the state. We can say that the state. Now if this state change from that point to P2 and V2 point, then we can say that this is process. The process is done. And the series of equilibrium state through which the system passes during its process is known as the path of process. Now how the process happens? The process happens by series of equilibrium state. Series of equilibrium state means P1 V1 to P2 V2. There is a long distance, there is a long path. The process has to be covered to become the process. So there are lots of state in between that, and that all are the points, and that will be in series of equilibrium state. So we can say that it is a path of a process, and further process can be divided in reversible process as well as irreversible process. A reversible process is reversible in nature. After reaching from one state to another state, it can be returned back to that original state uh, by recovering everything that has spanned to do that process, and it reversed everything. Like if we have supplied some amount of heat to do that process, it can be reversed. It can give us back that heat, and the process can be reversed. uh, but actually the reversible processes are not possible. uh, in, in the phenomena we know in the nature, it is not possible. So all the processes are irreversible actually, and irreversible processes are defined as the process which are not reversible are called as the irreversible process. And from that figure we can say that that one vehicle is moved from one point to another point. It takes some it consumes some amount of heat in case of a fuel, in form of a fuel, but it cannot be returned back to that initial point by giving back that fuel to us, and it is not possible ever. And there are major other phenomena also uh, not make that happen, like friction and all the other things. But we can say that the friction is the main cause of irreversibility. So these are the reversible and irreversible process, and the friction is the main cause of irreversibility. And after that, the quasi-static process. Quasi-static process. QC-static process is a really very important topic in case of thermodynamics, particularly. The QC means almost. QC means almost, and static means almost steady. Almost steady process. Let us understand this by considering first a spontaneous process, how spontaneous process occurs and how QC-static process occurs. Let us consider one container, something like piston and cylinder. uh, P1 and V1 is a pressure and volume inside that cylinder, and M mass is put on the top. Now if we remove that mass, then it will spontaneously the pressure inside that pressure of gas will spontaneously push that cover up to the that fixed level. Means the process will occur spontaneously because we have removed the mass, we have removed the weight, we have removed the lock on that particular thing. So the process will occur spontaneously, and all the spontaneous processes are actually irreversible. And this process we can define on pressure and volume diagram. But the process that is not defined, this is a process which is not defined because it occurs spontaneously. We cannot say that which process has been done over here. It could be any